Nonlinear systems of equations. Determine the number of solutions to the system of nonlinear equations. So now we have two equations. They are nonlinear, they are not lines, and we want to determine the solution. Well, the easiest way to do that is to find where they intersect. So the solutions to the system of equations is negative 2.52 and 0.52. Write the variable in isolated form. Sometimes we're solving for x, but this time we are solving for x squared. So we are isolating the x squared. So we subtract this little BFF couple. Okay, what do we get to do next? FOIL. So we're going to take y plus 1 times y plus 1. And we're going to get y squared plus 2y plus 1. Distribute the negative and combine like terms. Okay, let's look at the next one. Now we're solving for y squared. So we're solving for y squared. So we want to isolate the y. So we want to move everything else that can be moved. Next step, divide by 4. Everything divided by 4. And we are going to leave the answer just like that. You could combine because you have a common denominator, but we're going to leave it like that. Notice this time we only wanted to solve for y squared. Sometimes if we want to solve for y, then you have to take the square root of both sides. Solve using the square root method. So we're going to isolate our x squared. We're going to subtract 3x squared. Now we're isolating the x squared, so we move the 19. Divide by 5. X squared equals 7. Take the square root of both sides. X equals square root 7 or negative square root 7. And that's the answer. Okay, steps to using substitution to solve a nonlinear system of equations. Step 1, choose the variable to eliminate. Now, if one of the equations is in linear form, that's going to help. You're going to choose that variable. Or if one variable is squared in both equations, you're going to solve for that variable with the exponent, but not take the square root of both sides. Use inverse operations to isolate that variable. Step number 3, substitute the isolated variable into the other equation in the system. Now that the equation has one variable, we can solve the equations for that variable. Next step, substitute your solutions into any of the original equations in the system. Step 6, solve that equation for your second variable. And then step 7, plug them in and check your solutions. Luann isolated the variable y and then substituted it in to the second equation. So step 1, choose a variable to eliminate, and I'm going to choose the y. Next step, solve for y. Y is equal to x over 3. Next step, what do I do with this? I'm going to plug that in for the y value. X squared plus x over 3 squared equals 25. Or x squared plus x squared over 9 equals 25. So it did not say for us to solve this equation. It just says what the resulting equation is. Next, solve the system of equations. Zach isolated x in the first equation and then substituted it into the second equation. What was his resulting equation? Okay, to solve this system of equations, Zach isolated x in the first equation and then substituted it into the second equation. So we're isolating x. Divide by 2, x equals 4y. So now take this and you're going to substitute it in for x. 4y quantity squared plus y squared equals 9. So that's 16 plus 1 is 17. Y squared is equal to 9. Next, Zach isolated x squared in the first equation and then substituted it into the second equation. This is one of the examples where you have x squared in both of the equations. So that's what we're going to solve for. You also have y, but I choose x. X squared plus y squared equals 9. Solving for x squared is equal to negative y squared minus y squared plus 9. We subtracted y squared from both sides. Now, I am not going to take the square root because we're going to plug the value of x squared directly into the equation, the second equation. Negative y squared plus 9 over 16 minus y squared plus 9 minus y squared over 25 is equal to 1. That is the resulting equation. We don't have to solve that right now. Just write the equation.